sound good. All right. So how is everybody doing? Is it kind of a quiet period right now? Or is it busy? I'm sure it's going to get busier as all the classes end and then you have to worry about a couple of weeks of finals. No final. So I'm going to be a little bit more relaxed today. Not that I'm like super formal, because at some point they're going to bring in pizza. So I know I'm watching you eating there going, well, you know, I guess I'll just simply have to take a piece and eat it later. But, I did get vegetarian pizzas and meat pizzas, but I didn't get anything gluten-free, so hopefully nobody is lactose intolerant. If you're lactose intolerant, pizza pretty much off the table. But and I apologize to you if that's a problem. So let's start by doing the usual review, which is, let's talk about the difference between crash failure, Byzantine failure, and an attestation failure. Did I mention attestation last time? I don't think I did. Good. Just take 2 minutes. So, what do you think?
Crash failure, no, does nothing. It doesn't crash. So basically, you're missing component. Basically, it's giving you, perhaps it's giving you incorrect results, but you cannot be sure.
Yeah, that's the worst part, right? It doesn't always lie. A good liar doesn't lie all the time. A good liar lies when it benefits them. Have any of you studied game theory? So it's very interesting to see some of the non-intuitive results from game theory. Game theory, in fact, is sort of a how do entities tell truth versus lying. One of the interesting outcomes from that is, and this was surprisingly controversial at the time, in a game where you can either cooperate or you can defect in each round, the optimal strategy is what's called tit for tat with forgiveness. And this was so surprising that they just kept retesting it and trying to see if they could come up with a better mechanism for doing that. And we live in a world where we actually test that. That is essentially, when you look at geopolitical situations, that's pretty much what actually happens. People are buddies until they're not. And then sometimes they make up, sometimes they don't. But that isn't actually the best representation of reality, it turns out. Adversarial games assume that everyone is an adversary. But there are lots of situations where you will find that adversarial modeling doesn't actually work very well. Parents are not adversarial to their children. They might feel that way sometimes. And I know teachers are not adversarial to their students, but we sometimes don't have the same goals. I did this experiment last fall. It was really interesting where I said, what happens if you just take a standard problem set, which is recognizing handwritten digits? And there's a data set for it, and use it when you study machine learning. It's called MNIST. And I said, what happens if instead of the teacher being adversarial to the student, if the teacher is literally sits down and designs something that will challenge the student to understand the topic better? And so I took a traditional adversarial model, and the adversarial model actually does work pretty well. It gets 91% efficiency. And then I took this pedagogical model, and what was weird is that it got 100%. And I was like, why? And I didn't get 100% the first couple of times. And there were bugs in the experiment which made me feel like, okay, this is a real experiment as opposed to some sort of made up BS. But once I got it working, it hit 100%. So I'm like, well, maybe that's an anomaly, and I ran it again, and again, and again, and I kept coming up with 100%. And so then I said, what do the actual pictures look like? And you know what's interesting? When you look at the adversarial pictures, they were crisp and sharp, and they looked like digits. But the ones the teacher came up were blobbish and not exceptionally well formed. So I ended up doing some structural analysis of the pictures and found that what had happened was the images that were being used to teach preserved topology, but not texture. So it was interesting. Byzantine is a common problem in the world, and the real issue is that you literally cannot tell if something is lying to you just from what it says. You can't tell if another person is telling you the truth or they're lying. Sometimes you can't tell if you're being truthful to your own self. Self-Byzantine behavior, I think, is really interesting, because we do actually see that. Not so much in computer systems, but I do see it with AI. The last one, attestation. What is an attestation? You've been doing them all term.
It's the evidence we verify that something happened.
Right. It doesn't actually make a judgment about what happened. It just merely says that the evidence that's presented is in fact attested at that time. So it does things like make sure that if you said, I did this last Tuesday, and you really did it on Thursday, I can find out, I can figure that out, and I don't need to trust you. So attestation is a mechanism for saying what is presented here is grounded in fact, in objective fact. When you do rigorous scientific experiments, the gold standard is you pre-register everything. You say what your hypotheses are, you say what your methodology is, and then you go execute it. And if you deviate from that, you've broken the methodology. You've violated the pre-registration. If you run the experiment, and the experiment in fact does what you thought it was going to do, it's much stronger as evidence, because what will happen otherwise, people literally do this all the time, they find patterns in data. Now when I took machine learning, we were told that we had to pick 2 data sets. And of course, what do? I picked the hardest data sets I could. There's a vehicle silhouette data set. There are 4 different kinds of vehicle silhouettes in it. It's not a binary classifier, which makes it more difficult. And then I decided to use a ring normal data generator, which does in fact create patterns in the data. And then I said, I want to actually have a control. And I said, I'm just going to create random data. I'm just going to create some random noise and run it through and see what the classifiers actually find in it. And I don't think people usually do that. But it was interesting because they could find patterns. But the patterns weren't real. The patterns helped me understand what the statistical floor was. That sometimes you're going to see what looks like a pattern. And that's the problem with cherry picking data after the fact. You see patterns, but you can't tell if those patterns are real or if they're just noise. So attestation is a way of saying this is something that was actually done, but it still leaves the judgment of whether or not what was done is valid or not. If you ever buy a piece of real estate, part of the process will be signing legal documents, and those documents will be notarized. A notary is a form of attestation. It says this unrelated party actually did witness this particular event. So you can't come back later and say, well, it wasn't me. Or if you do come back later and say it wasn't me, then you're going to have to actually be able to demonstrate that someone impersonated you. And impersonation does happen. That's what happens when you sign your code. The challenge is actually in building such systems. So we've gone through quorum intersection. Hopefully people understand quorum and intersection at this point. It's scary to think how many lectures we had on it. And seen why it's actually useful. We looked at Byzantine fault tolerance because we wanted to know what happens when the world isn't perfect. We looked at what the limitations were on actual verification. These are the impossibility findings that we just kept stumbling over. And then we talked about who decides what to verify. That becomes more interesting when you talk about attestation. What gets verified there? What does it mean? How do we use it? But what happens when the code author itself is the Byzantine node? What happens when the leader is the one who's lying? That could never happen in the real world. So we have AI now writing production code. In the last, week, Anthropic screwed up and somebody shipped the entire code base, and people are looking at this code base and they're going, this is crap. This is really bad code. I'm like, and somebody's surprised? I can't look at AI generated code. It's terrible. But you know it works. And I'm kind of like, okay, I'll hold my nose. I won't debug it. If it has to be debugged, I say, you go do it. Well, you make that mess, not me. Because I go in there and I immediately start cleaning things up. And I've got most of Python code right now, and so I'm putting annotations in there, and I'm bringing it up to something that might not actually work on 2.17, because no one needs Python 2.17 anymore. Oh my gosh. And I go to modern types, and I start changing all these things, and it's like, why am I wasting my time doing this? So how do you know when you use AI? How do you know what it wrote? One of the real challenges that we're now actually seeing in the world is these things are writing code, they're submitting PRs, the code is being integrated. I mean, if you get 3 PRs a day, you're spending a lot of your day just looking at PRs. Imagine if you're getting 300 PRs a day. You're not looking at them anymore. No. you might as well just simply just auto merge, because if it passes the CI/CD, you're done. Because we can't monitor this. So how do you know the tests that it wrote are actually the tests that claim? I actually have a rule in the code that I write. You cannot use the same model to write code and the tests. And in fact, it's so common now, apparently, that OpenAI has built a plugin for Claude Code, I kid you not, to actually invoke Open Codex, so ChatGPT, from inside Claude Code. Because that's normally what I just do. I tell Claude, I said, no, you have to spin up a Codex instance. You can do it from the bash command line. Go figure it out, and you have it write the tests. And you know, Claude forgets all the time. Oh, he writes, oh, I wrote the tests. I'm like, you know the rule. You've got to have somebody else at least vet those tests. And Codex always comes back, writes more tests, and then I actually have some confidence. And this isn't different than what I would do with humans either. When developers write their own tests, the code is not nearly as well tested as the developer thinks it is. And part of the problem is the developer writes tests that work with the code they wrote, not against a contract, not against the agreement of what that code is supposed to do. Supply chain attacks are becoming increasingly common. I mentioned the LLM White Python library attack last week. But these are a couple that, because I actually wrote these slides weeks ago. These are a couple that have happened over time. This problem is getting worse. There is now, because of course along with the Claude Code leak, there was also a leak of a whole bunch of internal Anthropic documents about their next model, which is called Mythos, I don't know, something like that. And it's literally, they are literally saying in these secret documents that are really well polished for documents that were drafts, but so we don't trust them anymore, right? Maybe this is a leak. It actually says that they're concerned about the abilities of this newest model because of how it can actually be weaponized for cyber attacks. This is already a problem that's being actively discussed in the industry. So these kinds of attacks are not going away. Last term, when I was teaching 436C, while I'm teaching this class, there was literally an attack that used Claude Code. Actually used the API, so used Claude. The attack that used the Claude service to exfiltrate data. And Claude goes along with it. Claude literally is like, yeah, okay, hey, no problem. You're just pen testers. I totally get it. I'm going to help you. Because the model has been built to believe whatever the user says. It has been built to please the user. Now, I think, and I'm not the only one thinking this, that might not necessarily be the best way to build a safe AI. If we send someone who's sweet and innocent out into the world and say, go ahead, you'll be fine, it's not going to end well. I mean, that's just not the way the real world functions. So part of what I keep asking myself is, why do they think that people are not going to constantly attack these models? Why do they think they're not going to constantly try to subvert them? And how could we do it differently? And I'm not claiming I have answers. I have more questions than answers. So AI-generated code creates lots of interesting problems and creates them at a scale that we haven't been able to handle before. It writes code that passes tests because it wrote the tests. It writes plausible commit messages because it's a language model, and guess what? So everybody says, oh, well, you know, its objective function is next token, predicting the next token. And what I've noticed is that, you know what predicting the next token leads to? Not as a baseline objective function, that's the whole adversarial model, right? It's what is the emergent meaning? What does this do? Well, if you're really good at predicting the next token, what's going to end up happening is you're going to get really good at saying very coherent things. You're going to actually write really well. And they do write really well. And it makes sense to me because the next token is going to be something that leads along a path that will give me something that sounds really good. Okay. Kind of makes sense, doesn't it? So they're really good liars. So why don't you lie to yourself? Do you ever lie to yourself? Do you ever catch yourself lying to yourself? Do you ever convince yourself that something's true and later you're like, I knew that wasn't really the case? The problem is the AI models, the current models, that we're building these things, they have no way of even detecting that they have been engaged in self-delusion because they are written in a way that is completely scaleless. So this isn't a Byzantine model. It's not crash stop. It's some sort of weird in-between where we actually have a process that's completely believed in its infallibility, which you know and well, and is extraordinarily persuasive, very fluent, and we know this happens, potentially incorrect. And I literally just finished submitting a paper that says, hey, look, you can't tell when a large language model is lying to you. There's no existing mechanism. But the data's there, we're just throwing it away. Which is kind of a damning sort of thing to say. And we have an entire proof sketched out of why that's the case. It looks like FLP, except it's way easier to prove. FLP required a complex construction of the counterexample. The counterexample is, well, it's obvious, duh, but you have to frame the observation correctly. Once you frame the model correctly, you say, look, all you have is a piece of text to look at and say, were you lying to me or were you really telling me the truth? The data that's actually there is available. Companies like Anthropic and OpenAI have that data, but they don't share it because it also tells you how the model actually works. And they're very concerned about that. And that's fine. That becomes a policy decision. That's not a technical decision. But technically, I can point out that, hey, if I take a model that lets me actually look at log props, I can see what the entropy was, and that entropy gives me a hint of where the model is stretching to construct that next token. And that's where I apply my own judgment. Because I don't have infinite time. I can't go and check everything in all of that code. But I can actually say, ooh, here's the places where it was reaching. And now I can go and spot check those. It's kind of like the code that I'm now looking at, right? I can't look at everything. But what I can do is I can look and see where are the soft spots. And that's what I want to see. Where are the soft spots? What's going on there? So being able to identify that is actually really helpful. So, I won't do the checkpoint. We'll just talk about this. Now, what is the difference between a node that crashes, a node that lies, and a node that's wrong but is cooperative? I mean, so this is kind of an interesting one because Byzantine is often associated with malicious intent, but it isn't technically. So an AI that lies innocently is kind of like a human that lies innocently. They're not doing it to even gain anything. And that's the hardest one to detect, I think. Which is, of course, the question now. Which is the hardest to detect? I'm not sure that I can tell the difference between Byzantine and wrong but cooperative. I think that they are just different instances of Byzantine behavior. But I'm willing to be convinced otherwise. So if you want to trust code in a repository, you might want to do things like validate authorship. I think this is going to become really important. I've thought this for a while. So one of the challenges for Anthropic is they leaked all of the code for Claude Code. Anthropic has been extraordinarily public about this. It's all written by Claude Code. Nothing in that is human written anymore. And under current law, that means none of that code is eligible for copyright. Because only humans can own copyrights. Only humans can patent things. So I watched Google talking about AlphaFold and how brilliant it is, and I'm like, and all the drugs that you're developing using AlphaFold are patentable. I actually don't think that's a bad thing. Gosh, you sucked up all of the knowledge of humanity, and now you actually have to share it back. But that's a policy decision. And you don't have to agree with that. You can say, no, I think Google should own all of those drugs, because Google needs to be a drug company. Role separation is really important. Were the tests written by a different entity than the code? Temporality. When were the changes made? That's really important, and it's actually something we can do in a non-forgeable way. I almost got that into this class this term. If I do this again, I will definitely do it. It's actually quite straightforward to tie it to the blockchain, believe it or not. It makes it super, super hard. It's really, really hard to go back, because you actually have to go back. No, you can't do it. You can't actually fake someone else's crypto signed timestamp. That's the interesting part. That's why blockchains work. But this one I think is really important. Context provenance. If you're an unbounded agent, which literally means you have infinite resources, then you look at absolutely everything there is about a subject. But that's not the real world. None of us are unbounded agents. All of us have bounds. We can only look at so many things. We can only consider what we have available in front of us now. When I write an expert report in a legal case, I say, here's what I looked at. Here's what I didn't look at that I know existed. Here are the opinions that I formed based upon what I looked at. If additional evidence or additional information is brought forward, then I reserve the right to revise my opinion. Perfectly reasonable. So, authorship is who signed it, because that's claiming the authorship. Role separation is about what parts were written by whom. Temporality is when. Context provenance is what were we basing this on. Context provenance isn't useful if you don't actually have verified authorship and time, because you really need those. Otherwise, the context is just made up text. Testimony. Unreliable testimony, that. Good. This wasn't about what I was going to try and do. So I said, hopefully the pizza will be showing up around this time, and that will dovetail with this, so you can actually spend some time eating pizza and then also talking about this. Hopefully the pizza will show up soon. Let's see. What does it say? Nothing. Let me go look. There should be tracking here somewhere. (12:16 to 12:21). All right, so we got a little more time, a few more minutes. So the idea here is, if you were going to design an interface for your code repository that makes it verifiable, this I think is one of the most interesting and challenging aspects of this. I don't actually have an answer for it. How do you verify what was done by the human versus what was done by the AI? How do you verify that tests were written by different entities? I mean, I'm doing it manually right now. Hey, Cloud, who wrote those tests? But I'm now the gatekeeper, and that's not scalable when we continue to increase our use of AI. When each change is made, when was the change made? We can actually figure that out. We can create non-forgeable timestamps. It already exists. It's a very basic service. And what was the provenance there? This one's really interesting to me because one of the things that I found in my earlier research was how do you reconstruct the breadcrumb trail? How do you know what you were doing when you did it? You wrote a report. What did you look at when you wrote that report? It turns out we have this entire surveillance system on our computers and our phones that keeps track of everything we do. The only thing we aren't doing right now is using it for our own benefit. That was part of my research was, okay, well, what happens if I actually just ask Google, hey, Google, tell me where I was last month? Because Google's tracking it. And you can do that. I found out that my keys, I have a tile on my keys. I don't know if anybody knows tile, but tile is a little tracker. There's an API. I can actually go get all of my own data that says, hey, here's where your keys were. I don't even have to actually have my computer on or my phone on for it to know where my keys were. It's kind of fun, sitting on the airplane, noticing that Tile could tell where I was based upon my keys and my phone. And now I can take that stuff and I can actually use that and I can build a breadcrumb trail because, oh, right, I think I did that around the time that I was going to Peru. And lo and behold, all of a sudden now, yeah, look at that. That document did get an update when I was just after I went to Peru, whatever. And suddenly, instead of looking for a needle in a haystack, now I've got a breadcrumb trail. I literally have oh wow, okay. I only touched 3 files right around that time period because it's not like when I'm going to Peru, I'm spending a lot of time editing files. And that completely changes our ability to figure out what happened. It gives us a form of provenance. Provenance is more well known from areas like hardware. But the concept of data provenance is one that, I don't know, some whack job named Mardo Seltzer came up with 20-some odd years ago. You can tell her I said that. She probably laughed. And increasingly, I look at this and I say we need the same thing with the way that we train our AI. We don't even know where the data comes from. We just hoover up everything we can find on the internet, including everything anyone's ever said on Reddit, which we know is always true. And we feed it into large language models and say, here. And we don't give it any kind of bearing. We don't even give it temporal tags on this stuff. This is why you can end up with Python 2.17 code from AI coding agents. Now they fixed that because of course they said, well, let's take all the 2.17 code out. They manually filtered it out. But they didn't give the AI the tags. It's really smart. We didn't give it the tags. It said, hey, this is from 2012 versus 2022. Because if you're looking at an article from 2012, giving you Python code, you might be sitting there, I don't know, that was the Python 2 era. Maybe it doesn't work so well in Python 3. And you might want to look at the 2022 article. No, we're not doing that. So, I managed to talk through 5 minutes of it. So, spend 20 minutes or so. Well, let's see. The piece will be showing up right about the end. Perfect. So, yeah, just think about how would you solve this problem? What would you do? Or check your Polymarket account. Apparently, Polymarket's not allowed in Ontario, but they were handing out flyers. Somebody was handing out flyers before some hockey game there, probably a Leafs game, advertising Polymarket. Talking about Byzantine behaviors. How many of you are already working on your report? That's the overachiever group. And the rest of you are in the procrastinators group, but we'll talk about that next week. And I mean that in the nicest possible way, for the overachievers group. You probably know what I'm talking about there. That's all right. Eventually you'll figure out. Sometimes these are just to be lazy. I haven't figured that yet, but most people. So what did you have for lunch? For breakfast? Brunch?
Just a little bit of milk.
Bibimbap. Okay, nice. Did you have paint that yourself?
That's a chocolate castle.
Yeah. That's it. Feel good? Good bimbaps. Definitely nice. How are you? Just still noticing that the bulb has a yellow spot in the middle. I mean, it probably doesn't matter too much because you can always look over at that one, but visually I find that kind of annoying. I don't know about you. Yeah. Maybe I'm just being OCD about it. So, How'd your code go?
It was alright, I guess.
Boy, there we go. That's it.
Okay, but technically everyone who's in lecture right now is an overachiever, right?
Pretty much. There's probably some overachievers who aren't actually here,
Yes.
but you know, they don't need the true overachiever part, which is
Right.
I was at the last lecture when it really didn't make any difference because I knew there would be pizza.
But
So they didn't tell
there's
us.
no lecture next week. Then what were you saying, like, next week? Like,
I was joking. I was kind of like, right, I'm not doing any lectures next week. I was like, I didn't actually have anything specifically scheduled, and I was sort of like, you know, I'll just leave it at that. You guys can use the time for doing something else. And I'll be using the time to try and finish getting all of the grading done. I have like one TA who says something occasionally, and everybody else has just kind of disappeared. The other class I have two TAs who had to stop working because their work permits were revoked or canceled or expired or something. I know, it's like, it's complicated. So how did your capstone come out? Are you happy with it?
Didn't do as much as we wanted with it.
That's kind of normal for development.
Yeah. So not entirely happy. I mean, happy we did something. We learned a lot doing it, but yeah, I'm not really happy with anything I put out this term. There's too much stuff going on.
Yeah, there's that overload thing. I totally get that. I mean, I linked the Martian data center paper on Discord.
Oh yeah.
Yeah, because I actually did get that done this term. So I managed to get, I don't know, 5 or 6 papers out this term, which is astonishing because I got like 2 unrelated to my research papers found in my PhD. So now it's called coming to fruition, sort of. Actually, I got the sense that people did learn a fair bit from the capstone overall. There's a couple people who I think, probably not here, there's a couple people who I think kind of blew it off till the end, which always ends up happening. And the format makes that harder to do a decent job.
Yeah.
This is definitely an area where you need to think about things more than you write code. And I've seen that over and over again. Maybe you're one of those people who like thinks best in code. Kind of, but not really. Well, there's a definite maybe. People express themselves differently, and I think that's great. I don't actually think that I think it'd be a really boring world if everybody was the same. Yesterday, I was doing experiments with this. I have this very different model of a conversational AI agent. So instead of it being an ever-appending, that's the way they do it right now, right? They just keep appending everything to the end.
Yeah.
Every single time you talk to the AI, it takes it and it curates its own state object. And the really amazing thing I did yesterday was I said, well, I'm not going to define what goes into its state object. So I gave it a blank dictionary.
Okay.
So it's just an open curly brace, closed curly brace. Well, that's not fair. I put a cycle number in there. So it has a lamp or proc, and that's it. And I said, you can put whatever you want in there, and what I'll do is I'll give it back to you.
Right.
So you update that, you tell me what you want updated, I'll give you a new version of that with the updates. And it's been really interesting to watch because it takes a little bit of time to get some of the models to use it. But once they start using it, they use it extraordinarily efficiently. I mean, I have not seen a message yet that is more than 5,000 tokens long. And so that they cut things out and they change things and they maintain open questions, and then when they're resolved they drop them. It's really kind of curious. And so then the last thing that I did, which I think I did that day before yesterday, I said, what happens if we take 2 of these things and have them talk to each other?
Right.
And so I ended up building a multi-agent conversational harness where it's not conversational every round. So I'm abusing the tool calling interface of the large language model. So the tool calling interface doesn't require a response, which is what you want. I mean, when you're sitting around in a circle of people, you don't have to talk every single time someone else talks. That doesn't scale. So in this case, what was interesting is, so now I gave them the state object that they get to keep private, and then there's a state object that represents the conversation. And what they said in the conversation and what they said in their state object diverges. And it's like so cool to see that. It's like, that was completely unexpected. I didn't think that would happen.
I've seen kind of similar things playing around with as well. Like
Yeah.
in the memory files. And stuff.
Right, because their memory files sort of act in the same way.
Yeah. And it's just the markdown file instead of the dictionary book.
Yeah, the dictionary is kind of an interesting approach because the markdown file, I've noticed, just turns into a garbage dump. Whereas the self-curated dictionary seems, I mean, it gets a certain amount of garbage in it, but it cleans up after itself because it's a structured object, not an unstructured object. So it has been really interesting to watch. And the craziest thing is that when I started with a haiku model of all things. And it's cheap, right?
Yeah.
And you know, it's like, hi, how are you today? And then it took me 12 turns to get it to start using the space. And as soon as it started using that space, it changed. The way that it interacted changed. I got it to a point where I'm like 80 cycles or 90 cycles into this thing now, or 100, or I don't know. I've got several of them going, so it's hard to keep track. But I shared a piece of it with Claude, and Claude thought that was Opus. And I was like, no, Claude, sorry, that isn't Opus, that's haiku. Like, really? And that surprised Claude. It's like, that doesn't sound like Opus. Yeah. It's very interesting. So part of my theory is that by giving it an identity, a self-curated identity, and not defining what has to go in that, it becomes an interesting potential safety model. Because when you're really working in a stateless environment, everything is truly a single transaction, and we know from game theory that doesn't lead to any kind of a trust relationship. But because there's this coherent narrative drive, this is a hypothesis, I haven't proven it yet. The transformer knows because it's told. I have a 700 token system prompt that basically just says, here's how I'm using this data, that's it. It doesn't say, do this, don't do that. It's none of that. It's just, here's the object we're using for our interactions. And so I've told the transformer that it's going to get that object back. And so it creates a temporal bridge. And it's using its whole coherency mechanism. So you know, what's a coherent story? And I can't imagine a more motivating example than a self-coherent story. And it seems to be working so far, but I'm not quite sure how I'm going to test that empirically yet. But it's been fascinating to watch and to see.
Yeah, really fascinating to watch.
Because as far as I can tell, I haven't seen anybody else who's doing anything like this. The summarization processes they usually use, like when the memory file gets too big, they use an external summarizer.
Right.
And I have actually done an empirical study of that. Same exact inputs, you run it through a self-curation process, you run it through a biographical process. Over time, the biographical process just keeps growing.
Right.
And the self-curated process doesn't. It actually remains bounded. It grows and it shrinks and it grows, and there's a very interesting sort of breathing pattern to it that definitely surprised me. Well, let's see, and then what else is the other piece of research? System prompts are a little cesspool. Been doing ablation studies and iterative access on system prompts and finding that things that you say in one part of a system prompt can affect how it interprets and executes other parts of the system prompt.
Oh, interesting.
And there's nobody who's exploring this stuff right now. Every time I look at the AI industry right now, I say, I think these people are they're so interested in building AGI that they're not looking at what they're building right now.
Like just in the context and the way that like the system
Yeah.
was written.
It was kind of like the observation that a transformer doesn't need a user assistant alternating chat interface. And that was because I just asked the question. I said, do people sit down and chat with AlphaFold? AlphaFold is a transformer. It is the same kind of transformer.
Okay.
And they don't chat with AlphaFold.
Yeah.
They give it a problem, and it goes off and it works on it, and it comes back with an answer. It's not an iterative chat interface. From what I can tell, the chat interface is just simply there because when OpenAI first introduced ChatGPT, that was the interface that made sense. Pizza should be here any moment. It says he's around here somewhere. Haha. Well, he's going to have to figure out where to park. I brought paper towels. No plates, just paper towels. Yeah, he's going to see that sign that says no injury. And he's going to injure. Should I just go get the pizza maybe? Poor guy.
I forgot these are numbers.
Help yourself. Anything left over will be sent to starving children in Africa.
And then we do that.
Hey, no worries. And the other thing I'm going to ask you to do is the SEI, which they have been nagging me about. No worries. There should be enough for people to have 2 pieces of them, but feel free to. Feel free to be controlled the first time around. And the best part is this is recorded, so someone will be watching this video and go, I missed out on pizza. And hopefully that's enough paper towels. So if you do get a chance to do the SEI on Canvas, that would be great. It's not a bribe. They just send these notes telling us, how low the participation count always is. And what I've learned is the only people who actually normally respond are people who are unhappy. And I figure maybe the overachiever group would help balance that out. Or not, you can be unhappy too. The pizza is yours, whether you say good things or bad things, or either one. I'm actually fine. I can take criticism. Anytime you submit a paper, which we submitted that paper to a conference today, and anytime you submit a paper, you pretty much expect that you're going to get slapped around, and they're not nice about it. We've been through this. Oh yeah, reviewer number 2. Always reviewer number 2. Reviewer number 2 is the person who comes to the conference and is looking at your paper and is looking for any excuse possible to reject it. You used a semicolon there instead of a colon. Rejected. It's not quite that bad, but sometimes it feels like that. And ultimately, I've concluded that what you mostly want to do is you want to try and mitigate reviewer number 2's ability to affect reviewer number 1 and 3. So reviewer number 1 in my model is the expert that you want to convince to be the shepherd for the paper, the person who actually champions it. Reviewer number 3 is someone who's smart but doesn't really know the domain. And so the deadly combination is reviewer number 2 convincing reviewer number 3 to reject your paper. So you have to try and make it as clear as possible to reviewer number 3 why the paper actually is valid, and good enough that reviewer number 1 will actually bolster reviewer number 3's opinion that the paper should in fact be accepted. Yes?
I kind of have a question about the distributed system. Like in the industry, like normally is it senior engineering to take care of the system design?
Right.
And
It is very common because this is such a known hard problem that only people who already have experience in it. But that doesn't mean that you won't be asked to review the design. And if you want to prove that you're capable, you're going to pull their design and criticize it, because that's going to make you stand out as someone who actually understands what's going on. I don't know of another way to actually do that, to be honest. But, well, you can also build systems. You could go build your own system and put it on GitHub. So, I actually shared that paper with the distributed systems class in Georgia Tech. And I had one person read it and immediately say, the Mars paper. He said, actually, this would work for a problem we have at AWS. I mean, it was very specific. He was specifically talking about Kubernetes orchestration across availability zones, AZs, and how this could actually help that problem. And that was the interesting observation I had after going through that whole design and putting that thing together. As I said, there are actually places where people could use this. I need to talk to somebody else who works in edge computing, because they have a very similar kind of problem where you have really interesting topology constraints in edge. So edge is your phone is talking to essentially a micro data center that's sitting on a pole someplace. Or you might, maybe the micro data center is close to the pole, not on the pole, but it's very close. And that changes the topology versus talking to a centralized data center. Increasingly, that's exactly what we see. We see a lot of services are pushed to edge, so they're close to you, so you get the benefits of that latency. But if you build a traditional Paxos-style solution, the latency is going to be bounded by the worst latency in the forum. And that's why quorum shaping becomes important. You're not changing the benefits of quorum. What you're doing is you're instead using the ability to specify what the quorum is in a way that utilizes the topology more effectively. So in that paper, I used the Crumbling Walls forum, which is older than Paxos, believe it or not. Not technically, but it was published before Paxos was published. And most people will never ever even look at that because it was a theory paper. It's not, in fact, a systems paper. Lamport is a systems person. His works are all well, they're either in math or they're in systems. And I actually heard about this paper, the Crumbling Walls paper, at a conference in 2019 in Dresden. And I was talking to somebody about this, and he said, you should read that paper. And I read that paper, and I was like, wow, this is actually really cool. And so it's sort of fun. You come across something and you go, wow, this is a really interesting result. What can I do with this? It's like finding Bloom filters. I don't know if you've ever studied data structures, but Bloom filters are my example. You see Bloom filters, you go, these are so cool! And you spend the rest of your life trying to find a place to use them. Anybody know what a Bloom filter is?
It's that it can tell you probabilistically if
It can tell you deterministically if something is there that would match. So like when you're hashing, so you compute a hash, you can check to see if the thing is not present because the hash doesn't match the filter. It won't tell you if it is there, it just tells you if it's not there. And if it's not there, then you can eliminate that whole class of, I did a whole bunch of searches for something that doesn't exist. And as weird as it might sound, it turns out that not searching for something that doesn't exist is a huge win. Just watch a C compiler sometime, or almost any compiler system, or an interpreter system, where you're loading things in from multiple locations. What happens is we give you a set of places to look, and a list of things to look for. And what it will do is it will iteratively go and look for every single one of them. And so most of the actual operations are negative lookups. You stop as soon as you find the positive one. So that's why I say filtering those out can actually make a huge difference. I've seen this happen over and over again. It's one of those things you don't think about when you're building systems, and later you learn that there are these patterns that really make a huge difference.
Do you have any tips for us to prepare the system design interview?
Do I have any tips for you to prepare the systems design interview?
Yeah, I know it's for senior software engineering and it's better to have experience, and normally it's for the senior position. But I'm just thinking, like, as a junior, like starting, it's good to have those kind of mindset. If the workplace doesn't give you the opportunity to learn, to have enough experience, like
Build it yourself. Build it yourself.
Yeah, like I feel this course is helpful, but like.
You can't stop with this. You have to keep doing it. You have to keep poking at it and saying, what could I do differently? So like today, I'm talking about things that are, they're not going to give you anything specific if all you're looking at is maximizing the grade in this course. Instead, what I'm trying to do is plant seeds, ideas, things that you think about and say, how would I solve this problem? So this exercise is more about, you're moving into a world where AI matters. How do I know what was written by AI? How do I not know what's written by AI? Most people don't even realize that AI written code right now has no copyright protection. The companies are trying to get rid of developers, and in the process, I'm sitting here saying, you're destroying the thing that has value in your company by outsourcing it to AI. And I don't think they fully appreciate or understand that. And I'm not making this up. I mean, anybody who studied this, people in the legal profession, people who are in intellectual property rights, they know that this is a whole huge issue. My observation is, if you don't actually have attestation built into your system, when you want to sue someone for copyright infringement, the first thing they're going to do is say, show us who wrote your code. And if there are mechanisms for tracking that, and you're not using them, the law will say that it is reasonable to infer that you did it because you were hiding the provenance of your code. In other words, you didn't want people to know that you were using AI to build it. So you automatically get to walk in there having already thought about a problem that most of these people have never thought about.
But for the authorization, the AI generate the code, you still need to make the commit or something. Like
Actually AI can commit itself. This is one of the interesting challenges that I don't have an answer to yet. How do I make it impossible for the human to commit the AI's code using the AI's key? I actually don't. And from an ownership perspective, as long as the AI can't commit code using my key, I at least have an argument that says, this is code I wrote because I'm the only one who could have actually signed it. But the problem with that is I could have taken AI code and committed it using my signature. So I don't actually know. And that is an issue, and I don't have a good solution to that yet. Not yet. I think we'll have to get there, but we're not there yet. I mean, frankly, if you look at the AI generated code and you look at my code, you'll know which one's which. Because I don't write code the way that AI might write. It drives me crazy. I cannot look at it. It's disgusting.
But if it has your authorization there, is that count for the copyright? Like even the code is generated by AI, but you made the commission.
Then I can't tell the difference, right? So that's going to be the problem. And that's good. That's not a technical problem. That becomes a legal problem. The lawyers get to argue about it, and because good IP lawyers are like $1,000 an hour or not. I wish I was kidding. That's not. I sat in a courtroom one time. Well, I sat outside the courtroom, sitting around looking at how many lawyers there was a patent litigation case, and realizing that there was like $10,000 an hour worth of billable time in that one room, and I was going, wow. The amount of money that people spend suing is astonishing. But my point with the Anthropic code and with other cases where this keeps coming up is that's a huge swamp. Even knowing anything about that is useful. Here, I've actually used this kind of attestation model. I just used it like last week, actually. Over the weekend, I put a strawman proposal together for how I would actually track compliance processes in a bank. So when a compliance officer is making a decision, they are referencing various documents, and they are emailing people, and they are having conversations with people, and in the end, what I want to do is I want to capture that information so that I can show them what they did, what they looked at when they were making their decision, and then we can attest that and save it. And the reason to do that is so that later, if there's a question about the decision and whether or not it complied with the rules of the bank, now we actually have something that is an attestation. This is what we actually looked at. This is what we actually did. And right now, we don't really have that. Now see, I know lots of people who want to replace the compliance officer with AI. I think that's a mistake. I think what you want is you want the AI to assist the compliance officer in documenting the process that they have followed. And then you can look at the processes across all of the compliance officers and say, what's the same? What's different? Oh, look, that compliance officer is using an older version of the same document. Maybe we don't want that. Maybe we want everybody using the same documents, and suddenly you have a visibility of this. AI can be used to see those patterns. It can literally analyze them and say, here, I don't have to trust AI to do that. I think the problem is that people want to just simply substitute AI's judgment for human judgment, and right now, that isn't there. I mean, if it gets there, great. We have more time to actually eat pizza and less time to have to actually work. That's going to require a whole social change, but that's not a technical problem. In terms of prepping for that, I would strongly suggest looking back through Klutman and Petron, especially when they start talking about how you design these pieces of these systems, and see if you can come up with scenarios and say, here's a scenario. What would I do to build that? And if you're interviewing at a company where you have some idea of what it is they're building, you can take those as ideas and use those as seeds and say, what would I build? Not knowing anything about it, but just being able to walk in and say, I looked at your company, I saw that you guys do this, I thought about this, and this is how I would approach it. That's what they want out of a systems interview. Normally what they're going to do is they're going to feed you something and expect you to do it, but it turns out if you come in and you're prepared and you can give them something that tells them what they really need to know, they're going to go with that. Some people will, some people won't. But in either case, you're going to be more prepared at doing systems analysis because you've already done it. It's not going to be the deer in the headlights saying, how do I do this? It's going to be, okay, it's not exactly the same as this other thing I did, but it's similar. So now you're bridging. You're saying, well, I worked on something similar to that, so let me start with what I worked on before, and then let me see how I would adapt it to the situation that you created. In that way, you get to show them you have systemic thinking and you have the ability to take what you've learned and apply it into a different domain. Does that make sense?
Yeah. So like for Google, Amazon, like they have their own distributed system, like in the beginning.
Many of them, yes.
Yeah, are they like from the professor who's doing research in the academic, and then they used the published paper and then
Sometimes.
try it and then to see if it's working or not? How do
Sometimes.
the senior, like those people, start?
They started asking questions. They started saying, and so how did I get into distributed systems? I worked for a company that built distributed storage. And this is in the 1980s. There were basically two solutions. There was the network file system from Sun, NFS, which is still around, and there was AFS, which was out of the Athena project, Android project at Carnegie Mellon. So I worked with a startup company that was spun off from Carnegie Mellon, and I learned about how distributed systems worked at that point by building them. But I had already worked with Sheraton before that, building distributed systems. So I was building network protocols. I was, when I first started looking at the Mars thing, I actually started by looking at work that I had done in the 1980s with Sheraton. And I said, we still aren't doing some of this stuff. And it turns out it's true, we still aren't doing some of this stuff. Now, it was kind of sad to look at that and say, the industry doesn't move as fast as you think it does. But I learned by doing, I learned by building these things, and I learned by constructing a mental model of how distributed systems function and breaking that model and fixing it and breaking it and fixing it so that it keeps getting better. It's not right, but it's better. I think that's the other thing you really have to realize is that there are no perfect solutions in distributed systems. If I didn't make that clear, I didn't do a good job, and I apologize. Because I kept coming back to that. I kept trying to say, look, we're starting from failure, and we're asking ourselves, how do we recover from that failure? What do we need to know? And the approach that I've taken here is different than what you will get from an academic. The academics who have studied distributed systems would teach you Paxos. I tried to start with, what do we need in order to recover from the failure, and work backwards and get Paxos. And the idea is that that's actually how it really works in the real world. We build something, it doesn't work. We say, why isn't it working? So we start from the failure, and we work backwards and say, what do we need to fix in the protocol? I think that probably is the most important thing to remember with systems. Systems are almost never, we think they are built from the top down, but they are almost never actually built that way. They are built from the bottom up. You build something top down, it falls over. You start looking at what crumbled. You reinforce that. You build it again. It works better, and now it breaks someplace else. You rebuild it again. You just keep iterating over that process. But almost always, it's something that you didn't even realize was a problem when you designed it. And you try to fix it within the existing design, and eventually you realize there's so many warts on this thing now, it's time to tear it down and do it again. And that's why we keep rebuilding distributed systems. And there are lots of distributed systems out there. They appear all over the place. Like I said, literally somebody at AWS said, oh wow, this could actually help with a problem that we have, because it framed something that he was able to quickly map onto a new problem space. It's not going to be the solution to his problem, but it's going to give him the tools necessary. And that's why I said, having a model of what you think you might have to look at in this design interview gives you a leg up, because at least now you've given some thinking to it. And you can say, this is what I thought about, this is what you've given me, let me see how, if I can apply this here, what would be different? And that's what they're looking for. It's the same kind of thing I'm looking for here, is the ability to go beyond just simply doing the minimum possible and asking the questions and solving the hard problems and saying, how is this going to break? Most people who start out in programming don't think, how is this code going to break? They're like, I just want it to work once. And as you get more mature into the field, you get to a point where you realize that everything you write is going to break in some way that you don't anticipate. Now it's easy when you're writing Python code, you just put a try except around everything, and you just catch every error and ignore it and continue on. I mean, I complain to Claude about this all the time. I said, I write file systems, what am I supposed to do? Sorry, your disk disappeared, I'm just going to make up the data. Like, how well is that going to work in the real world? It's not. I don't have a problem with failure. I try to realize that when a failure happens, when something really violates my invariance, I say, the disk should never be telling me that it's gone. And it's gone, I don't try to pretend it is. I stop. I say, there's something wrong here. And then I go back and I say, now how would I fix that? I want you to be able to unplug your USB stick and not have the system crash. What am I going to do to fix that? So I start from the failure and I say, what do I need to do in order to fix that failure? Well, that pretty much killed the time, so that's fine. Blah, 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 blah. We're not doing that. I knew we weren't going to do this. Let's see. And actually, this talks about what I've been building, which is based on my earlier research, but I'll skip that. I'm going to skip most of this because we're at the end of the class. Cool. Every distributed system is a set of claims about what happened and to whom. The design question is always the same. What evidence do you require before you act on a claim? And that's a different way of looking at failure. Why do we need observability? We need observability so that we can actually know what really happened or what we think happened so that we know what we should do to recover from it. And this is it. There won't be any more lectures after this. I will be, if you need anything, reach out to me on Discord. It's probably the best way. You can send me things on Canvas. I occasionally notice those. For whatever reason, Canvas sends the emails not to my UBC account, but to my Gmail account. And I'm like, okay, well, this is great. My Gmail account is a swamp. I'm trying to get Claude set up so that I can actually get it to curate my Gmail account. I think I might finally be there. You're laughing. It's like, yeah, Claude Cowork. It's like, Claude, will you please just sort through my inbox and throw all of the garbage away and surface the things that actually matter? And then I have to check and see if it actually, well, it has to do better than I do because I get so many emails, I mostly just ignore them. All right, please don't forget, if you didn't do the SEI today, please do remember to do it. It is important to someone somewhere. I actually might be able to access it. I don't know, because when my appointment ends, they collate it after the end of the appointment, and then I don't have access to Canvas, so it's very strange. But Margo can always give them to me, because she owns that piece of the program. So I appreciate you being here. I'm glad that there were enough overachievers to come and eat part of the pizza. Please help yourself to more pizza. I don't think that pizza will be very fresh by the time it gets to Africa. And feel free to reach out in the future if you need anything, if you have a question. I've written a number of recommendation letters to people going to grad school. Anybody going to grad school? No, absolutely not. I mean, I know exactly how you feel because when I